WSP Denmark. I've been working for WSP for around 13 years. And 6 years ago, I finished my PhD about controlling the discharge of stormwater into streams. And since I've been working with discharge permits, and I'm a senior specialist within the field of hydraulic and chemical impacts of discharge concerning stormwater. We have faced a lot of regulatory challenges today in Denmark. Not that it is a problem, but it's because we are part of the EU, and EU has a water framework directive stating that all designated water bodies need to achieve good ecological status and good ecological conditions and good chemical status. Sorry. This applies uniformly across the entire EU member states, and it makes it necessary for us to control and have a stricter control on pollutant discharge, including those originating from stormwater runoff. If any of you are not from the European countries, you might wonder, why should we care about this? But actually, this, even though it's a bit problematic sometimes, the European standard actually represent a sound and a coherent framework which could be applied across the entire world. So I think you should listen anyway. This is a European Water Framework Directive, and the way Denmark has implemented this framework is perhaps someone would say a little bit ambitious, but we have designated most of our water bodies actually. So what you see here on your right-hand side is the map of the designated surface waters in Denmark. When you work with legislation like the Water Framework Directive, it can sometimes be a bit tricky to interpret. So someone like me, who works with discharge permits, loves when we have some verdicts. And this is an example of 5 verdicts. That's because the verdicts interpret the legislation, so we can actually understand better what they mean. I promise I'll go through them very shortly, but it's important for what I'll tell you about. There's 3 very important European verdicts. The first one is the Land Nordrhein-Westfalen from 2020, stating that deterioration applies both to a quality element and a substance. I'll tell you more about that later. Then there's the very important Weser verdict from 2015, established the criteria for what constitutes for deterioration, even when the current status is in the lowest class. It actually says that the competent authorities is required to refuse approval of a project when it could result in deterioration of the status of the surface water body, or where there is a risk that good status of the surface water may not be achieved. I'll show you how we include this in our calculations later on. Then there is the Association Française Nature Environment verdict from 2022, stating that even temporary deterioration without long-term impact may still be considered deterioration. So we have some strict regulations here. Then we have 2 verdicts. We changed our the way we assess the discharge permit a lot in Denmark within the last 2 or 3 years, because we had some verdicts, changing the entire way everything worked. The first one was the Holstebro verdict from 2022, stating that assessment of the impact on a designated surface water body required knowledge of the current status. So if we're discharging into a water body, we need to know the status. So we need to know the concentration of all the chemicals for this matter. And I can admit to you that we don't always do in Denmark. So that sometimes be a bit tricky. Then we have the Horsens verdict, which was the one showing us that we needed to take this serious. It said that in case where the status is below good, and then any additional load is considered a deterioration. I'll show a little bit more about the Horsens verdict, because actually the WSP was helping the municipality making the discharge permit. It is for this area. It's a road connecting the motorway and an industrial area over here. The problem was that the pre-existing concentration in the stream down here was actually exceeded the EQS, the ecological quality standard. The calculations showing that it was not a problem was made in accordance with the Danish EPA guidance. The calculations showed that the discharge would result in increased concentration at 2% of the EQS. The discharge was 2 liters per second, so very little, into a stream with around 1 cubic meter per second in the mean flow. So what happened was that the pre-existing concentration was rising from 1.717 micrograms per liter to 1.751 micrograms per liter, so an increase at 0.034 micrograms per liter. And you could say that's very little increase, and that's true, but it was an increase, and the concentration was above the EQS at 1.48. So the Board of Complaint of Environment and Food told us that's not okay. You need to make this better. And because the calculation was made in accordance with the Danish EPA guidance, it was withdrawn during the night, and we waited half a year for it to return, and it has been changed a bit 2 or 3 times ever since. So so there's happening a lot in Denmark. What difference did it make? Before this verdict, when we assessed a discharge permit, we looked at the ecological standards, the plants, invertebrate, fish, and algae, and then we said, okay, the water is cleaned in accordance with that. Then the environmentally hazardous substances is not a problem. Everything is okay. But now we need to remember the Land Nordrhein-Westfalen verdict stating that any substances should be assessed like a quality element itself. So every substance with a requirement is actually just like plants, invertebrates, fishes, and algae, a quality element. So how many quality elements do we then have in Denmark? Today, we have 45 EU prioritized substances, and we have above 130 national specific substances. And I know this is in Danish, but I will try to explain to you what it means. The substances is spelled around the same way, but then we have a general criteria and a maximum criteria in both groups. And then we have for the inland waters and for the marine waters, they might be different, the EQS. And for the European specific substances, we also have, some of them have criteria in accordance to biota, and the national specific substances, there is a lot of them are also having a criteria according to sediment and biota. So we have a lot of substances that we need to assess every time we make a discharge permit. But how do we do? I'll just show you shortly how we do it. It might looks a bit more tricky than it actually is. In Denmark, we assess normally loaded separated stormwater a bit different than we do with point sources like a wastewater treatment plant. So I'll show you how we do it with the normally loaded separated stormwater. It's basically the same, but a little bit different. When we assess the effects of a discharge, we look into the concentration in the discharge, and if the concentration of a certain substance is below the EQS, then we say it's okay. the discharge is below the EQS, just discharge, but we need to assess the sediment requirements. Usually we say that the biota requirement is met if the general quality standard in the water phase is also met. If the discharge is about the EQS, it might still work because the EQS works for the resulting concentration in the water body. So we need to assess the resulting concentration. And then we need to remember the Weser verdict stating that the impact must not result in a deterioration of the status of the surface water body. And if it's above the EQS, the impact in itself must not prevent achievement of good ecological status. If we start here at the left-hand side, we calculate the resulting concentration. If the resulting concentration is not above the EQS, everything is fine. But if the resulting concentration is about the EQS, there must not be a measurable increase of the pre-existing concentration. So if both of them are exceeded, we have a problem. We are not allowed to discharge and we need to do something else. But if at least one of the requirements is met, it's not a problem. Then we just need to show whether the discharge in itself prevents achievement of good status, good chemical status. So we dilute our discharge into clean water with no concentration and see if the resulting concentration will be above the EQS. And if it does, it is a problem, no matter whether it's not a problem over here. And if it's below, it's not a problem. So we need to assess both of them. So actually the calculations that we make is not very difficult, but the the assumptions that we make sometimes be a bit tricky. So one of our customers asked us to do a project about environmental hazardous substances, and they asked us if there were any types of catchment area which was unproblematic concerning the concentrations. Then you also asked us how many substances, for how many substances we do have data, and which substances is problematic. So that was some questions that we need to consider for some time. We did an analysis, and this showed which type of catchment we do have. I'll tell you later what I mean. For which substances we do have data, and for which substances that the concentration has been measured about the EQS, and for which substances we think we have problematic concentrations, but we don't have data. We started the analysis by looking into which substances should actually be a part of our analysis. Of course, the EQS, the environmental quality standard, should be a part of the EQ in the analysis because that's in the legislation. But then we also assessed the environmental quality criteria, which was only guiding a concentration, but still they should be a part. So we ended up with over 300 substances that we should assess. Then we looked into which sources of data should we use, because there is actually many sources, but many of them with limited data. So we ended up with 3 sources that we used. The first one is a Swedish database called Stormwater, and it's based on international literature study. So every time there is a new study of stormwater, then and concentrations, the Stormwater try to implement it in the database. They have a lot of catchment types because some of the studies has been made on a very specific catchment, like parking area or this type of roof or something. So they have a lot of catchments, but with a limited data on some of them. Then we looked into the Danish database called Rainwater Quality. They had the data from 2018 and older. Actually, they now have new data, but that came after our project. All of this is now it's in Danish, but I just want to show all of this is catchment types. We have roads with different ADTs and yellow daily traffic, and they also have old data, and they also have limited data for some of the catchment areas. Then we had a publication from the Danish EPA, which was only for open urban areas, and they had semi-old data also. So what we could see, and the reason why we need to make a disclaimer in our report, was that there was many uncertainties to the data that we looked into. And we also saw that when we compared newer data to the old data, there was a significant difference. But we did the project based on the data that we could find, so the older data. Then we started figuring out how many types of area do we think that we have in Denmark, where we can say that there is a significantly difference between the types of area. And we ended up with 5 types of catchment in the analysis. First of all, we had the dense urban areas like city centers with a higher load of traffic. Then we have the open urban areas with detached houses and a lower traffic. Then we found a new type, which was new open urban areas. So areas that we make now, focusing on the materials, for example, the roofing materials, and making it without sinking copper, which is some of the metals that we have many problems with. Then we have industrial areas, and we made the major roads with an ADT at 5,000 to 25,000 cars daily traffic. So that's what we were doing. Then we looked into, okay, which substances is actually problematic, and we made this analysis for all of the catchment types that we looked into, and I'll just show you an example for the open urban areas. Here we saw that actually for around a third part of the substances that we looked into, we had no data, so we don't know if they're problematic or not. We later on made an analysis showing which substances that we actually thought was problematic, but we didn't have any data. Then for a third part, we had data, and for this data, we showed that 2/3 part of the measured data was actually below the EQS, and 1/3 part was above the EQS. I won't tell you all the substances, but I'll show a list of the substances that we found was problematic in the influent data. My colleague Søren Gabriel will having a webinar next week showing you which data was problematic after cleaning and how we could clean the stormwater. But this is the problematic data in the problematic substances in the inflow. And why is it problematic? Because we are looking into the resulting concentration, and if the water is clean in Denmark, then there shouldn't be a problem, hopefully. The problem is that the water is not always clean in the pre-existing concentration. So we could take an example for one of the streams that I have been working with. This is the one at the right-hand side. And just look into the discharge of zinc into the stream. The inlet concentration is around 130 micrograms per liter, and the expected outlet concentration when cleaned in a wet stormwater detention pond is around 30 micrograms per liter. The general EQS in the water phase is 9.4 and the maximum EQS is 10. So if we have an urban area at 10 hectares, so not very big, and a discharge permit at 1 liter per second per hectare, so 10 liter per second, into a stream with a mean flow at 50 liters per second, with a pre-existing concentration at 7 micrograms per liter, so below the EQS. The resulting mean concentration will be 7.88, which is perfect because it's below the general EQS. But then we have the maximum concentration, which will be above the EQS. So actually, we're not allowed to discharge. And if we look at another example, I just changed the pre-existing concentration to 10, so above the EQS, at least the general. Then we'll actually rise the pre-existing concentration, the resulting concentration to above the pre-existing concentration, giving us that we are not allowed to discharge either. So because we have so much agriculture, for example, in Denmark, we have a lot of zinc and copper in our streams. So often it's difficult for us to actually discharge the rainwater when I have a water body which is not clean. So that's some of the things that we're working with and how to assess what can we then do. And I don't have the time to tell you what we do then right now, but I'll just sum up my presentation, stating that all stakeholders should meet the EU requirements for achieving good ecological and chemical status in the water bodies, because it is actually some good requirements in order to make sure that we have some good water bodies. There is an insufficient knowledge about several substances, making it difficult to actually determine which is problematic in relation to to stormwater discharge. For example, we don't know very much about tire chemicals, and this is a big focus in Denmark right now because we have so many roads and they need a discharge permit. And what do we do then if we don't know what will come from a road? Then we have a number of substances that has been identified as problematic across different types of catchments. And what we are looking into is source control for, among others, zinc and copper. Could we remove it from our from the materials that we use? We didn't identify any catchment which was free and unproblematic, because there is substances in every type of catchment. But we do see that we need some valid analysis of the inflow and discharge concentration of stormwater. And this is important for the entire stormwater management sector, that we know what we're actually working with. So time for questions, and thank you for listening.
Thank you so much, Anja, for that insightful presentation. So yes, I have a couple of questions already on the chat. So the first one is, does the database include concentration limits or guidelines that might be applicable elsewhere? Are they receiver dependent?
No, I don't think they're receiver dependent. It's you need to show. I'm not sure that I interpret the question right, but but you need to figure out which type of catchment is the one that you are focusing on, and then figure out whether you actually believe in the data or not. And that's some of the task that we use the most time to do. So, as I said, it's the assumptions, what data we should use, that takes the most time. I hope that was the correct answer to my questions, to the question. But yes, I believe that it's applicable elsewhere. You just need to choose what you believe in.
Thank you. On that note, there's someone that asked if maybe you know if there's any knowledge of these kind of testing or requirements being done or considered in the US.
Actually, there's a lot of American data in the StormTech database, and actually also almost more than in Europe. And I know that actually there is some literature studies also in the US. So there is a lot of knowledge. I'm not sure whether the requirements is in the US.
Okay.
But the studies is there.
Okay. Next one is, are there any innovative green infrastructure approaches you've adopted to address the stormwater quality challenges?
Yeah, we are looking into making local cleaning of the stormwater instead of those big stormwater detention ponds as we have always done, because we can see that the green infrastructure is actually very good at cleaning. Like if you will listen to Søren next time, there's different kind of cleaning cleaning effects. And in Denmark, we have traditionally used sedimentation in the wet detention ponds, but actually we see that if you have both sedimentation and adsorption and filtration through the soil, it gives us much better cleaning efficiency, especially for the non-particular substances. So yes, we are trying to adopt a lot of different cleaning methods in order to clean our surface water much better.
Okay, I think I received an clarification in the first question. He says, Hesham says, I meant the effluent limits may depend on the receiver stream water quality, whereas receiver stream quality will require lower limits. Any comment?
Yeah, I think the limit. I need to read, I think, but I think the limit should be the same no matter how clean and dirty our water is, and the limit is to the resulting concentration in the water body. So okay, so if it's depending on the receiver stream, yeah, you could say that if I think I understand the question now. Sorry. If we have a very high quality stream, then the limit should be lower than if you have a very bad stream. But actually, we set the limit towards high quality every time, so we don't look differently whether it's a good quality stream or bad quality stream, or whether so the limit is made based on when we are affecting the ecological quality, as you could say. So when you are affecting the invertebrates, for example, that's the limit concentrations that we have set. I hope it makes more sense now.
Okay, thank you so much. Okay, I think that's all the questions. I just have one more comment from Hani, and a question, but only thanking for your sharing the knowledge you have collected. Interesting to get acquainted with this knowledge. Highly appreciated.
And I appreciate to hear from any of you who has some experiences with this also.
Exactly. There's the information from Anja to reach out if you want. And thank you so much, everyone, for attending. And you can wrap up, Anja.
Good. Thank you for listening. And yeah, have a nice day, everybody. Glad you wanted to listen to me.
Thank you so much. Have a good one.